This is section 10.6, and this is on odds. So a lot of people will use the words odds and probability interchangeably as if they are synonyms, but they are actually not. They both are used to kind of tell you how likely something is, but probability will tell you how likely something is kind of out of the total, whereas odds will tell you the likelihood versus the unlikelihood. So kind of writing that out, probability is written out as the number of favorable outcomes out of the total. So it's the number of ways for something to happen out of your total. Now, I'm just calling it, these favorable outcomes just to, Alex uses the term favorable, unfavorable. That turns into a mouthful to have to say over and over again. So I kind of shorten it by just saying, wins and losses. So favorable being a win, unfavorable being a loss. So probability is just going to say, hey, how many ways are there to win out of the total? Odds are going to compare your wins to your losses. Okay, so let me show you a specific example here. Suppose you roll a fair six-sided die. The probability in favor of rolling a 2 is 1 out of 6. There's 1 2 on a die. There's 6 total outcomes. The odds in favor of rolling a 2 are 1 to 5. Now here's the thing. You'll notice that how I read those. I said 1 out of 6 here, and here I said 1 to 5. The way that probability and odds are spoken is even different. Even though they're both written as fractions, the way they're spoken tends to be different. So this is 1 out of 6. This, because the way that it's spoken is different, we do tend to not write them as fractions. We tend to write them as something like 1 to 5, or we'll use a colon. So these are the two more common ways that odds will be written, but just know that it does mean the same as this fraction. That's important because sometimes you can reduce the fraction. All right, so if the odds in favor of an event are given as A to B, whatever those numbers happen to be for A and B, then the odds against the same event are B to A. Now, the way we write that is we would say the odds in favor are A to B. Typically, we'll use a colon or the word to. The odds against, just flip it. That's because this wording in favor tells you that you're in favor or your wins are coming first, and then your losses. The odds against tells you that your against number comes first, or your losses come first, and then your wins. If the odds in favor of an event are A to B, then the probability in favor of the event is given by this formula. I'll explain that a little bit more as we go. Okay, so what does this mean in everyday language? In everyday language, the odds of actually mean the odds against something happening, okay? Now, what these do is these odds will tell a gambler what the likelihood of winning is and the payoff of a bet. Okay, so let's say that a horse track gives Limpy the horse the odds of 100 to 1. Remember, the odds of is implying the odds against, which I feel like is kind of weird because when I hear the odds of something, I just naturally think in favor of. I don't know if that's how you think as well, but it's weird for me that the normal, thing is against. So Limpy here has the odds against winning of 100 to 1. That means that Limpy the horse here is 100 times more likely to lose than to win. The probability against Limpy winning is 100 out of 100 plus 1. So it's this formula up here, which is 100 divided by 101, or 0.99. That's 99% chance that Limpy is not, going to pull out the win for us. Now, also what it tells us is that for every dollar that you bet, I was about to go to the next example, but I forgot about this part. For every dollar that you bet, if Limpy does win, you win $100 plus your bet back. So these odds will also tell the gambler, what they're going to win, as well as how likely, or in this case, unlikely it is for the horse to win. Okay, so first example we're going to do is homework problem 3. And it says, find the probability given the odds. And the odds that were given are 9 to 10 in favor. And then it says the probability of the event is blank. Okay, the odds in favor. The in favor tells you that the first number is your in favor, or your win number. The second number is your loss. There's always wins and losses, right? So win and lose. This tells you which one's first. The probability, remember, is always out of your total. The odds will always split that total into wins and losses. So your probability in favor is the number of in favor. In this case, we know that number is first, out of the total. Because it's a probability, this is our total. That win plus lose number, these two are my total. So this is that formula that I gave you, that the odds in favor are A to B. The probability in favor is A over A plus B. I'm just not using the formula because I'm going to try to explain this in a little bit different way without just formula crunching here. All right, so probability, we have this total of 19. The odds will split 19 into two numbers that add up to be 19. Those two numbers are going to be in one of two ways. They're either going to be the win first or the lose first. That order is determined by this wording. Okay? So when you go to change this to a probability, if it's a probability in favor, I need to know which one of these numbers is my in favor number. In this case, it's 9. And then a probability tells me it's the total. So I need to pull these numbers back together. So it's just 9 out of 19. All right, so homework 4. The odds against something is 15 to 4. Find the probability of the event. Now, this is implying that it's the probability in favor. Okay, so the odds against are 15 to 4. That means this first number is my against number. That's my lose number. Then 4 is my win number. This is the probability in favor. So the probability of the event happening. That's the probability in favor. So I need my win number to be on the top, because again, it's in favor. So that means I need to grab the 4. And it's a probability, so I need my total. So 15 plus 4 is going to be that 19. So I wanted to show you how these were similar yet different. Because this one gave me the odds in favor, this one gave me the odds against. In both cases, I had to add those numbers together in the bottom because it's a probability. The number that I put on the top depends on what it's asking for. This said in favor, so I need to figure out which one of these numbers is my favorable number or my win. that is told by what we're given here. The odds in favor tells me the in favor numbers first. The odds against tells me the against numbers first. Okay, so this one is like homework problems 1 and 2. We're given that the probability in favor of some event, and it's called just D, is 1 out of 7. This is going backwards from what we just did. The last two we did had the odds given first, and then we had to change them to probabilities. Now we're going to take the probability and we're going to split it into odds. This is my probability. This is the probability in favor. That means my in favor is on top, and it's a probability, so that number on the bottom is my total. This means my odds are going to split the number 7 into two numbers that add up to be 7. Not just any two numbers, but the number 1 and something else that's going to make it add up to 7. So, spoiler alert, it's 6. All right, let's find the odds in favor. All right, so the odds are going to split that total of 7 into two numbers that add up to 7. All right, the odds in favor means the favorable numbers first, then the unfavorable. So the wins first, then the lose. This number right here tells me my win. That's 1. I don't know what this number is, but I know it totals up to 7. So if this is 1, this is the rest of 7. All right, so I have that 1 coming from right here. That's just the rest of 7. Now, I'm taking a slightly different approach than Alex is with these. Alex takes a more formula approach to these, and I put this on the formula sheet even though I really don't like it. If the probability is the probability of E, then the odds in favor are given by this formula. I really don't like this formula. I find it to be way too convoluted. So I much prefer for us to just kind of think about the odds as splitting that total apart and the probability pulling it back together. I feel like that is an easier way of doing it than the formula. But of course, if you read through how Alex does it and you like how that formula works, you are more than welcome to use it. Okay? Now, the second part of the odds against. The odds against are super easy, all right? Whatever the odds in favor are, the odds against are just going to flip it around. Just boop, boop, that's it. So if this is 1 to 6, boop, 6 to 1. So the odds in favor and the odds against are the exact same numbers. The order is just flipped on them. Okay, so this one we're going to use a 52 card deck again. This is homework number 6. Find the odds against drawing a king. Okay, so we're talking about the odds. So we just need two numbers that add up to be 52. All right. Against means that the first number is going to be the number of ways to not draw a king. And the second number is going to be the win, or the number of ways to get a king. All right. So we've got this. So we've got 4 kings. And I don't have to count up the rest of the numbers, right? If I've got 4 kings, the rest of the deck is not a king. So it's 48 cards. The odds against means the first number are your not kings. That's the 48. And then the number of kings is second here. So that's 4. So I just counted up 4 kings in a deck. I didn't go and count the other 48 cards. I just knew that, hey, 4 of them are kings. The rest of the total must be not a king. So I just subtracted that 4 from 52. This can reduce. So before I go to the next one here, you might see this written in Alex as 12 to 1. Because 48 to 4 is the same as 48 over 4, that fraction, that's the same as 12 or 12 over 1. So you might see these written as 12 to 1. Either one is okay. I prefer to leave my answer unreduced here so that I can continue to emphasize how we're taking this total and we're splitting it up. All right, find the odds in favor of getting a black card. Okay, so the odds in favor, that means I need to know the favorable, the number of black cards first, and then the number of non-black cards. Well, half the deck is black and half the deck is red. So 26 cards are black, 26 cards are red. So we can write this as the odds of 26 to 26. Now, like I said before, this colon, this word 2 for odds, means the same thing as division. So if we do 26 divided by 26, we get 1 or 1 over 1. You might see this written as 1 to 1. Anytime you see odds of 1 to 1, that means that both outcomes are equally likely. So you're just as likely to get one as the other. Part 3, find the odds against getting a diamond. Okay, so that means we need the number of not diamonds in the deck to be first. So the number of not diamonds is 39. That's because there's 13 diamonds in a deck. Remember, there's 13 cards per suit. So if you need this to be able to count that there's 13 diamonds, and then that's the rest of the deck. Again, I just taking that 13 away from 52, or knowing that there's 13 cards in each suit, so the other 3 suits have 13 cards, so 13 times 3 is 39. Either way. But against tells you the not is happening first. So it tells you that these diamonds, this is how we're splitting it up, that total of 52, and this tells you what number is going to come first. This does reduce as well to be 3 to 1, but you certainly don't have to reduce it, even in Alex. It might tell you to reduce your answer, but if you just hit OK and submit it anyway, it should not mark it wrong. All right, last example for this section is homework number 5. We are rolling 2 fair 6-sided dice. Part 1, find the odds in favor of getting a sum of 10. All right, so we're back to this again. So remember how we had this, and I told you could just Google that anytime you needed it, just like with the deck of cards. We want a sum of 10. And remember, the diagonals have those sums being the same. So it looks like right here is my sum of 10 diagonal, the 4, 6, 5, 5, 6, 4. So it looks like those 3 outcomes right there are the number of ways to get a sum of 10. So the 4, 6, 5, 5, and the 6, 4. So the odds in favor of getting a sum of 10, because it says odds in favor, means that I need these 3 outcomes to come first. That number comes first. And then the second one is going to be the number of ways to not get a sum of 10. That's the rest of the total. These 2 together make up my 36 total outcomes. Now, how did I know it was 36? Well, this grid right here is a 6 by 6 grid. So there's 36 total outcomes. We were told that back when we first encountered rolling 2 fair 6-sided dice. We were told there's 36 outcomes. Here, I don't think it's explicitly stated in Alex. So you'll just have to remember that, or trust me. All right, so this odds in favor means that this number, this 1, 2, 3 outcomes, comes first. This does reduce, if you wanted it to be 1 to 11, but you don't have to. And then let's find the odds against getting a sum of 5. All right, so part 2 here, a sum of 5. So let's find the diagonal where we get a sum of 5. Okay, so we got that 1, 4, 2, 3, 3, 2, 4, 1. So it looks like that diagonal right there. So we have these 4 options to get a sum of 5 out of the total of 36. Because it says the odds against, I'm going to put the against number first. So I said that there were 4 outcomes that give me a sum of 5. That 4, 1, 1, 4, 2, 3, 3, 2. So those are the 4 I counted. This is the rest of 36. Remember, your odds will take your total and split it up into 2 pieces. This number will tell you which piece comes first. Your probability will take one of these numbers, put it on the top, and the bottom will be adding those back together. Okay, so that finishes up section 10.6 for us.